Get up off of that thing. Come on now, let's move it. I want to talk about ANOVA, but before we get into any of the math stuff, I just want to build some of the intuition as to why it works. So here we've got our number line. Instead of being horizontal, we're going to prop it up vertical. And here's our category and some data that we've analyzed. This data being all in a straight line, some of it kind of covers over each other. So I'm going to spread some of it out, make it like larger here. Okay, so can I simplify the picture even easier? Yeah, let's draw the median. In fact, let's put the box plot around it. Then you don't have to look at the actual dots. Just to simplify, we're talking about this group of data for this category. Now we can talk about lots of different categories, 4 of them. The way it's drawn right now, all 4 of these categories, the data is pretty much the same. It's got the same shape and spread and distribution and average. There really isn't a difference between these categories. Keeping track of which category you're in doesn't really make sense.
Remember, when it's over out there, we're all on the same team.
But here they're different. These averages are at different places. So if you want to predict what you're going to have as your value, you need to understand which category you're in. That's our goal, is to be able to test, are these means different or are they all the same, meaning the categorical variable isn't really helping us. So let's look at 4 different scenarios. Here's scenario 1, scenario 2, a third, and here's our 4th one. Now, look at these guys. Which scenario does it seem like the groups are different from each other? And which scenario does it seem like the groups really aren't that different? Most people would agree this one is where they look very different from each other. And here, it looks like not so different. Maybe they're only different by random luck, as you got some different data making it look like the means don't line up perfectly, but they don't seem all that different. What we're looking at here is the difference between the variability of the means, which is very spread out because they have very different means, and the variability of the data, which is not so spread out because those box plots are really small. On this guy over here, the means are very tightly close together and the data is very spread out. The other 2 scenarios show means very spread out and data very spread out, or here we have means very close together with the data also very close together. It turns out these 2 scenarios are actually the same. We've just zoomed out for this one so that you can see more there. So when we talk about wanting to know whether these groups are different, we want to compare these 2 variances, which is why it's called an analysis of variance, ANOVA. And we've seen this idea before. This is the classic z-test that we've worked with a lot. We've got how different are the means, being x bar versus mu, and how spread out is the data. That's the sigma over the square root of n for how spread out those means should be. So this idea relates to a lot of advanced statistical courses, even at the higher level. Our goal here is to test whether the means for these 4 groups could be equal. So what are we looking at? The variability between the means, in this case large, and the variability of the data, in this case small. If we turn that into a fraction, what we get is called an F. This was a distribution developed by Snedeker in honor of Fisher, who has done a lot of great statistical things. Here's his picture. The F does not relate to anything yelled by students while trying to do this homework.
Fine.
Large F, which is what you get when you take a big number divided by a small number, tells us those groups are very different. This scenario, on the other hand, is going to give us a small difference in the means and then a large variability in the data. That fraction is going to lead to an F, which is going to be a small number. Small f value is going to tell us those groups don't appear to be all that different. The other 2 scenarios that we had up here would give us a large number divided by a large number. That's going to be somewhere in the middle. Could it be the value of 1? Well, it depends, right, on exactly what these numbers are. Here we have a small number divided by a small number. Again, somewhere between big and small for these scenarios. There's a few things we're glossing over here, such as we still need the assumption of normality, which that normality assumption we've needed for other tests that we've done. We're also ignoring sample size with these pictures. Maybe this group has a little bit of data and this group has a whole lot of data. That should matter. We need to be able to account for that when we do the math. But this video is not about the math stuff. I just want to give you some pictures so that you have an idea of what we're trying to do here.